Welcome to NTOP Core Training. My name is Sunatasha Singhara, and I am an Associate Onboarding Engineer at Entopology. I'll be taking you through the basics of Entopology today to help you get started on your own journey of exploration of the software. If you haven't already, please download the files from the box link that I've put in the chat. In those files, those PowerPoint slides that I have up right now are included as a PDF file, along with all the part files that we'll be using today. The completed NTOP files of the workflows we'll be going through today are also there for your reference. We'll be spending most of our time today inside of the software, but before we dive in, I want to give you an overview of what you can expect to get out of today's session. The purpose of today's training really boils down to three things. First, we'll slowly build up your understanding of the concept of implicit modeling. This understanding is crucial, and you'll see later on why, because it influences how we interact with the software in order to create our workflows and designs. Then we'll go over some key operations that will help accelerate your learning. And as we go, you'll be introduced to some of the best practices that will enable you to work more efficiently within NTOP. Especially as you go on to create more complex workflows, these tips could help to make your files or your life and the organization of your files a lot easier to work with. I will walk you through everything block by block. You can see here what we'll be covering in each section. Block 1 will be more about the fundamentals, while in blocks 2 and 3, we'll start to create those simple workflows using example parts as a kind of exercise that you can follow along with as you try to wrap your head around the software. We'll now get into the first block of this training, but we'll always come back to this slide after each block to take some time to recap and digest all of that information. And please feel free to leave any questions in the Q&A at any time as we go. I'll come back to answer them at the end of each block. Now, NTOP is meant to be used to complement and work with your current engineering workflows. So we don't typically start from zero. Instead, we import into NTOP things like CAD or mesh files that have already been designed, or even in combination with other engineering data and test results, for example, from structural analysis and optimization or CFD. We then use these inputs as references to create complex geometry and designs that are difficult or impossible to do elsewhere. We can export what we've done in NTOP into files and data for the next design iteration, for manufacturing, or for files to be further analyzed or optimized in external analysis softwares and solvers, depending on your application. So here below this moving gears, you can find a link to an article on our Help Center that lists all file types that NTOP can take in and export, which you can explore in your own time. But essentially what we do in NTOP is not creating a specific part. We are building a process that can work on any part. So this means that whatever we build can be reused, and thus this term reusable workflows. To make use of NTOP's implicit modeling technology, which makes it possible to reliably perform modeling operations without ever breaking our geometry, and also allows for that increased design complexity, automation, while at the same time reducing the file size. To take advantage of this technology, we need to learn to work with implicits, which is NTOP's native format. Unlike in the traditional CAD software where boundary representation is used and you create geometry from sketches and work with faces and edges, as you can see here on this image, kind of those boundaries that are joined together, NTOP works quite differently. And it does that by storing this as a mathematical equation that describes the same geometry and volume behind the scenes. And with given input parameters, it computes this equation and then spits out the visual representation on the screen. So this visual representation is called the implicit body. And as you can see here, there are no edges or faces, just this volume and a field that is associated with it. And this is also what makes it easy to convert each file type you see on the left into one another and back. One big difference to the traditional CAD is what we call the notebook. Both of these are kind of there to keep record of your modeling operation, but whereas in CAD, you have your starting points, such as sketches, and then build dependencies on dependencies to create your design. In NTOP, you don't really have to have one starting point. The order of these blocks doesn't have to be sequential in the order that you've created them. And this gives you more power to do multiple processes in parallel and make more complex geometry at the end as well. And the way that you would organize the order of your blocks in the different sections within your notebook would really depend on your preference and how you understand the chronological steps of your workflow. Each block in NTOP serves a specific purpose, and each block takes in a certain set of inputs, then use that information to automatically compute the output. So if you have some coding experience, you can think of NTOP as kind of like a visual programming language. If you're used to working with CAD software and you're just getting started in NTOP, you might have to learn to get used to doing all of your operations inside the notebook without directly being able to edit or manipulate the geometry like in traditional CAD. Because as I mentioned before, the geometry that you see on the screen is just a representation of these equations we're trying to parameterize with our choice of inputs. But that's also what we're trying to do today to get you comfortable with the idea of working completely with the blocks. And all of this will make a little bit more sense once we get our hands on inside the software as well. So with that, everyone can go ahead and open up a new instance of NTOP. While you do that, I want to show you a little bit of what we have in the appendix here in the slides. This is all there for your resource. So here we have an image of these hotkeys. We'll be using some of these today, and I'll talk about them more when we use them, but this image is there for you in those PDF files if you need it afterwards. There are also some additional information on the blocks, on variables, which we'll talk about today, and then some additional reading resources, short video tutorials, and a link to sign up for further advanced training. So without further ado, let's jump into our NTOP instance. Let's take a look now that we have our NTOP opened. You see a few example files here on the welcome screen, and you can look into these files that have already been created to see what kind of things you can do without having to make them on your own. On the right, you have access to some news and other information resources. We can still access some of these once we get past this welcome page as well, and I'll show you where that is now. So what we're going to do is click on that new file. At the top right-hand corner, you see these three buttons. This little downward arrow will turn green if there's a software update available. You can click that to update, IT permitted. And this question mark button is really good. The documentation can be a really great reference for you, especially when you're starting out, as it contains basic information on different features in the software, including block types, input and output data types. So I'll leave this page open for now. Now, if we see what else, so the about and the what's new are just, this one has information about the licenses, the version you have. What's new is a page under documentation that tells you the release notes and what's coming up in each release. Support, let's go ahead and click on it, takes you to our help center. And if you ever have a question on how something works, type some of the keywords into the search bar, and most of the time you'll find answers to your questions, at least for when you're getting started. So here in this getting started section, there are some basic short video tutorials that's also linked in your appendix as additional resource. if you click on this knowledge base, then all these articles that you can search up are divided into different sections. Now, if we go back to the home of that help center and scroll all the way down, there's this button to contact support. If you still can't find the answer to your questions on there or need troubleshooting help, this is the next best thing to do. Contact support through this button, and they are the best equipped to handle your questions the fastest. And I really can't stress enough how helpful this help center is. So please make use of this available resource. You can see here that the color of my instance and my background is dark gray. I prefer this because it's easier on the eyes, but if you do want to change this, we can go to File on the top left corner, then to Settings. And this are some of the settings you can change for the different options to configure your layout of the software. Under Display, you have this theme, which you can change to light, and that would require a software restart. Viewport, you can just also change it right here to light as well. There is an option to toggle on a display grid, and you can change the size of that grid. The ruler, which you can move around and roughly measure your part. We have the options to have 2 different unit systems, metric and US customary, an option for autosave, as well as we have a traditional modeling ribbon that you can see up top. So here is where you can go in and hide any of those tabs that you don't use. Under general, we have a few other options, and I want you to all click on this show beta block so that it puts up a new tab in the ribbon where beta blocks are currently living in. And what they are is blocks that we're actively developing, and we typically roll out new software updates every 2 weeks. So these blocks could still be changing, but as the blocks mature, they will soon be merged into the software. So once you get more comfortable with the software, it is nice to be able to see some of the new capabilities that are going to be coming out soon. And as well, there's an option to enable GPU acceleration. And if you check this box, it starts to use your GPU to render out your geometries instead of the CPU. And this could be quite a lot faster. If we go back to the menu bar and go to this view, there's also some of the shortcuts to those display settings that we've seen before, as well as some of the hotkeys we'll be using. So you could do that by clicking on these as well. There's also an option to capture image. Another place that you can go to is this cube right here. This is called the view cube, and you can see these axis indication with the color corresponding to each axis. You can use this view cube to adjust the view of your part. Let me toggle. So if I click on this arrow, I can also turn off the display grid as well. And now if I add something to my notebook, let's say this cube, I can use this view cube to adjust the view of my object. So with this arrow, you can have a few other different options, including setting your own perspective and view, as well, again, as this capture image. If you look towards the bottom right of the screen, you see here there are options to change the resolution of our geometry rendering. What I really want to point out is that changing the resolution does not affect the actual part. If we are on lower resolution, it may result in some visual artifacts, but that just means that we are sacrificing some image quality for faster loading time that it takes to render the image you see on the screen. And so keep that in mind, and I always like to keep mine at medium res. This arrow, you can show and collapse this window that shows you the timestamp, as well as if something is loading, how long it's already taken to load. You can add a block to the notebook in a few different ways. The first way you just saw that I did earlier is by simply clicking on one of these icons. And if you hover your mouse over these, you can see the name as well as a short description of that block. And if you go to this tab at the bottom and click on that drop-down menu, these same blocks are there again in list form. So it's a duplicate of what you see as icons. So you can choose whichever one you prefer. The block will appear in the notebook wherever you have this white line. So if you want to make sure that your blocks show up when you're adding to a certain section, then you'd have to just make sure that this white line is under that specific section. The second way to add a block to your notebook is by using this search bar right here. As you get more proficient with the software and are more familiar with certain blocks that you tend to use often, this is a faster way to get to those blocks. And sometimes there are a few options for blocks that do the same thing, but maybe, for example, use different types of data. This is also a great way to explore your different options by typing in a keyword. For example, if I want to know my options for export, you can see here through the list, every single block that has that word export in it. So that's a great way to explore your options. There are other ways to call for blocks from inside the notebook using another block as well, and I will show you that later today. You can explore all of the different tabs in the ribbon more on your own later as well, but basically the blocks are organized into different categories like create, modeling, lattices, field, math, simulation, utilities. That's where you get that import, export, and conversion functions, as well as manufacturing with slicing for 3D printing, as well as this beta tab we talked about earlier. These 5 tabs towards the end are what we call the toolkits, and they contain prepackaged workflows and some other utilities specific for different applications. You will have the chance to learn more about these in more advanced training sessions, and I have included a link to sign up for these advanced sessions in the appendix of that PDF as well. So if you haven't already, you can go ahead and sign up for that. So if I add blocks from different tabs to my notebook, as you can see here, I have something that's quite colorful. And this is because we color code our blocks based on the type of the output data that each block produces. So to find out what each of these colors mean, let's make use of that documentation that we had opened earlier. There is our documentation. And here you can, if you go to using blocks, types of blocks, a little bit of information about the different ribbon tabs here. And underneath, you see these block colors and the associated data types. So this green is that NTOP implicit body. Fields are also green as well, because if you remember that I mentioned that implicit body have fields associated with them, since they are closely related, they're also green, just a different shade, as well as all of these other different colors that represent mesh and CAD files or lattices and simulation, etc. So take some time to go over the different sections of this documentation on your own later on. At this point for you, I recommend these 4 sections. So using blocks, using notebooks, reference, and block documentation. Let's now take a closer look at what we call the block anatomy. And essentially what that is what a block is made up of and how it's structured. So as I'm showing you these, feel free to click along with me and do what I'm doing. It'll be a good way for you to get used to working with the blocks. Just make sure you have this one cube block from the Create tab right here. Don't worry about the rest. I'll be deleting them from my notebook very soon. So every block has this name at the top. The bolded text on the left side shows the primitive name of that block, and the italicized text on the right is the name that you have given this block. So if I double click right here and type in the name that I want for it, say my cube, and press enter, then I have assigned a name to that block. Every block also comes with a set of inputs. You are required to fill these out in order for the block to run. There are icons next to each input, like so, showing the data type of that input. So the same thing goes for the icon that's next to the name, and that shows the data type of the output of the block. If you hover your cursor over this icon, you can see that it says the type of the output as well. So this is a box type. If we pull up a box, that's also a box type. That's because a cube is just a type of a box. So along with the colors, these icons can tell you that information about your block. This is something to watch out for when you try to use a block as an input for another block. The data type should match. And some blocks, like this add, has this little downward arrows next to the name. And this is what we call the overload. And this allows us to change the type of the inputs that are in here. So with this add, if instead, right now it's scalar field and scalar field, so we have input 1 and input 2 as both scalar fields. But if I do want to change this and say have temperature and scalar, then we can change those input types. And as you can see, that also affects the output type as well. So for all of these blocks, if you click on this question mark, you can see some information about the block. So this information tab contains the description as well as a breakdown of the inputs and what each one is. You have the output and what this block can convert to when it is a variable. And we'll talk about that a little bit later. You can go into the properties, and there are these chips that you can drag and drop into another input field of another block as well. So you can use these properties as input. We have display color changing option, as well as the comment. So there are two ways to comment a block. The first way is by typing that into here. The second way, if we click on the left-hand corner of this block, there's this bubble, you can click on it. And then if I type something in, and press enter, that shows up as well in this comment section. So this is good practice to do as you're building your workflow as notes within the notebook. So these will serve as notes for you when you come back to the file after a long time, or if you're sharing this with someone else. It's good to know exactly what happened there. But remember that these comments that you add are specifically attached to that block. So sometimes people like to comment with steps 1, 2, 3 as they understand the workflow. But if you do move this block later on, then that comment will go with it, and it could potentially ruin your steps if you commented that way. So that's something to keep in mind. Some blocks can be populated and filled in with values quite easily, like these ones. But in others, you also have things that say empty input fields. And if this is the case, we can always double click in that field to see a list of suggested inputs. And what this does is it tells you what can go in here, what is allowed to go in here. So these first things that show up with the icons are things that we have already added to the notebook. So blocks that we've already created will show up first on this list, and then the list includes everything else that can possibly go in here. If the block isn't filled out properly, you'll get this blue question mark. And if you click on it, there's this message with blue shaded area that tells you what's wrong with it, that it is an unfilled block. And sometimes if there is an error, this arrow or this question mark will turn red, and then you'll also have this red message telling you what type of error you have. And typically the error is related to the units or incompatible data type. If you ever run into errors, first thing to check your units and the input and output data type to see if those match. So now I'll be just working with the cube. So I will go ahead and delete everything I have here. And to do that, you just press delete on the keyboard after highlighting each block. So now if I want to move this object, this cube that I already have, the first thing you can do is press Z on your keyboard. And what that does, it zooms to fit. And then I can right click and then drag this around. That will orbit the object around its centroid. To zoom, you can scroll your mouse wheel or control right click. To pan, we can click and hold on that mouse wheel. And another option for that is to press shift and right click. So now let's go ahead and add a sphere to my notebook by clicking on that under the Create tab. And now I have this block highlighted, and you can see the object is also highlighted. If I just want to see the sphere, I can isolate that view by pressing I. If I want to turn on the visibility of my cube, again, I can either click on this circular symbol and put that back on, or press V for on and off visibility, V on the keyboard. So now, if I click on this sphere and I press F, let's toggle off the visibility of this sphere. What we see here is a field. So let's give it a little bit of a contour interval, 1, and then probe values. What a field viewer is it allows us to create sort of like a window where we can see into the field that's associated with our implicits. This field that we have is infinite. It is continuous in all directions, and because implicit equations are basically what return a value in all points in the 3D space. And so this field viewer is just a section plane view of what is that infinite and continuous in all directions. So we can change the plane that we view this field as well. Or we could do this to see it in different angles. We can even choose to change the size of this, because it is just kind of like that window, right? To see into this field. So what you have here is at the boundary, you have this color change. At the boundary of our shape, we have 0 millimeters. And that's our sign distance field that tells information about our object. So as we are moving further and further away from our body, the number that we have from probing our values is increasingly positive. And the same thing going inward, it's increasingly negative. So our radius of the sphere is, let's change this to a good plane so we can view it correctly. So now, at this center, the farthest amount of distance away from that boundary, we have -5. So that same size as the radius. Good. So if now I want to put my sphere at one corner of the cube, there are a few different ways to do that. I can click into the input field of my center point, and I can drag this and kind of roughly place it somewhere that I want it to be. Or if I know exactly where that is, I can type this into my input, and that would put that sphere in that location that I want it. The problem with this is if we change the size of my cube to 20, you see that this sphere didn't come with it. And this is because we don't have any sort of dependency. So to establish that, what we can do is go into the properties of the cube by clicking on this question mark symbol. Again, we go into the properties. Let's scroll down and find our max point. And this chip, you can also see the values here. We can drag that in to use as our center point, and you can see now that the sphere showed up at that corner where I want it. So now if I change my size back to 10, it's also going with it. If I want to maybe make the radius of my sphere based on the cube size, there are two ways to kind of do this in the notebook. So I can already go into the math tab, for example, and pull out this block divide, because I know I will have some sort of dividing operation going on. Or another way to do this, and this will make the object disappear because we're deleting that radius, but we can call for that block from within this field. So we can go ahead and click on that, and you can see that it is nested in here. Let's delete that divide block outside. And we can make this cube size, right click and make a variable. If you try to right click in the field, that won't work. So now we have a variable that jumped outside of our block. So you can see, I will name it something that's easily understandable. So cube size, and you can see that it is highlighted where it is referenced as well. So if I pull that into my operand A, that's also another place that it's referenced. So it is highlighted. And now I want it to be divided by 2. So now if, again, I change this cube size, that ratio of the size between the two objects are now dependent on one another, and that ratio stays the same no matter how you change this cube size. So now let's create something we like to call the sphere cube. Essentially, we've already made that, but now we're going to have to do a final step of merging them together. So let's go to the modeling tab and then go to Boolean Union. Click on that to add that. I'm going to drag that down here. So to add the two together, we can just drag and drop these blocks into this. And you can see here, it is a list, and you have the option of adding more items. So you can add or delete those lists, drag and drop your cube and sphere into each of the fields. And now we have a merged body. This blend radius gives the area where the two bodies meet a smoothing effect. And this is especially good for when you shell and lattice infill something. It is good to add that blend radius to where the lattice meets the shell to help against things like delamination. And you see this waterfall effect. This is because we didn't make anything a variable. This can be hard to follow if you come back later. And if your workflows get longer and more complicated, this you can probably imagine how big of a pain that could be. And so one way to kind of prevent that is to right click on that cube block maybe and make a variable, and that will pull out this block so that it's kind of outside of this nesting, and then reference it as the chip. And now you see in this shaded area, my name that I've given it that used to be on the right side jumped into this shaded area to indicate that it is now a variable, and that primitive name just got pushed a little bit to the right. So now with that being a variable, we are also able to change the type of data. For this cube, you can only have it as box, but now this cube size is also a variable. So you have the option to change the data type of that input as well. Now, a little bit about variable. Generally, if you know you're only going to want to use something once and forget about it, it's part of the process that you don't have to change ever. You can leave it nested. Variable is you can, when you make something a variable, you generally want to be able to see it and change the specific parameter quickly and easily without having to go into all of this nesting to find it. Or if you want to use it multiple places in your workflow, like here, like this cube size. At the end of the day, though, it all comes down to your preference and how you want to organize your workflow. But best practice is to make sure you make use of those variables to keep track of your steps and the different design variations to make sure you have a good overview of them at first glance. So now if I click on this body and press F again to access our field viewer and then toggle off this visibility. You can see if I drag this throughout the different parts, I can see that it follows the shape of my object. And let's do good practice and right click, make this Boolean union block a variable and call it sphere cube. One thing to note too is NTOP doesn't delete anything. So we've created this sphere cube by merging those two objects together, but we can still, if we isolate our cube or our sphere, those are all still there and they can be reused again and again in the workflow. So keep that in mind. So we have everything still that we have created. So now I'm going to go back to that slides. And before doing that, I will collapse all of these blocks. So you can do that by either using this arrow or pressing spacebar on your keyboard to kind of make this all nice and collapse. And I will name this as good practice, sphere cube. So what we've just done is we went through the concepts of implicits and fields. We've used some of the hotkeys and then explored blocks in Notebook, as well as that basic Boolean operation with our sphere cube. Since there are no questions, I will move on to our next block, which essentially what we're going to try to create now is we have a mesh file that we're going to import, and we're going to shell and gyroid this part after converting it to an implicit body, of course. We'll introduce the concept of toolkit block and custom block, and then show a little bit of that perforation that you need for additive manufacturing applications. So this is the final structure that we're trying to get with this block. Before we get started, I want to introduce a little bit of the different lattice types that we have in NTOP. So we have two types of lattices. The first one is surface-based lattices, and it is created as an implicit body. So there are two types, and they are either TPMS or wall TPMS. And TPMS stands for triply periodic minimal surface. And what that is essentially is it made up of these cosines and sines in the equations. And so you can see these creates the domains. And the difference between the walled TPMS and TPMS is just this walled TPMS has this solid part hollowed out, creating two domains instead of one that you see here. And they are 6 different fill types, and the most famous one is the gyroid. Now we also have the beam-based lattices, which are created in graph lattice form. And it is either periodic with 30 unit cell types to choose from, or stochastic. And periodic is, as the name suggests, it is just periodically repeated across the structure. And stochastic is kind of more randomized effect. Now let's go back to our NTOP instance. So I'm going to now create a new section and name this gyroid gear. And then let's maybe collapse this section. So now, before we collapse that, we have to toggle visibility off. Now we want to import our part, and there are a few different ways you can do this. The first way is import through this file import, and that will have this window show up, as well as you can see all these file types that you can import. The second way is to use one of these blocks, import part or import mesh, depending on what you're using. My favorite way is if we go into our folder, wherever we keep it, and just drag and drop. And that will recognize the type, of the file that you have and then created a block out of it. So now we want to have this part converted to implicit. So we have to go to utilities conversion and then grab this block implicit body from mesh and drag that mesh in. Let's collapse it. We don't really need to see it. So now it has created our implicit body with no edge or surfaces. So what I want to say now is if you get lost at some point while trying to follow along within these next two sections, and it can happen since this is a lot of information to take in, a lot of little operations here and there, feel free if at some point you get lost to just sit back and watch me continue. It is quite important that you understand some of the concepts I'm going to be introduced. So try to follow along as much as you can, but you still have that completed files that you've downloaded to play around with and try to understand afterwards as well for your reference. So you can come back to those later. So now that I have imported my part, I can now make this block, also right click, make variable and change the name to gear. I can leave that collapse because I don't need to ever change it again. And then now let's see the inside of our part. So if we select this body and press X to see the cross section, we see it is a solid. Now we want to shell this. So let's grab in our modeling tab. There is a shell block and the body is just this gear. So we'll drag that in. Let's give a thickness of 1 millimeters. And we're shelling this inward. So if we now isolate this shell and it is loading, and then press X to see our cross section again, you see that this is now hollow. And that happened very quickly. If I X out of this and press F to see that field a little bit, toggle my visibility off, you see that where it is hollow, you have this blue because it is not where you have the volume. So this is what you have as the field. So now that we have the shell, I know I'll be using this, so I'll make it a variable, right click, make variable again, and call this shell. I need this shell to be able to create my gyroid region because we have to think about what operation we have to make in order to get that region, right, that we're trying to infill. So it is just a simple Boolean operation. By going to this Boolean and take this Boolean subtract, we will subtract our shell from this initial gear to create our gyroid region. And now I will maybe change the display color so we can see it, and then press X again to see that cross section. So what we created with this Boolean subtract block is in pink, and it is that inside region. So I will right click, make this a variable and name it gyroid region. This will be used as the base to create our gyroid structure. Now we need actually to go to the lattice tab and choose our walled TPMS block that we will be using to create that gyroid structure. And we can drag and drop this as the base of our gyroid. I'm going to change the cell size to 5 and the thickness, approximate thickness, 2.5, fill type, gyroid. And you can see the loading bar is going on. Let's isolate this by pressing I. And here's what we have created. And then now the last step that we have is to just Boolean union the shell and this structure together. So let's right click, make this a variable again and call this our gyroid info. Grab again a Boolean union block, and I'm going to just drag in the shell and the gyroid infill into the two bodies. Now, if we isolate this by pressing I and then press X to get our section view, now we have completed our shelling and gyroid infilling workflow. And I will just right click, make variable, and name that again, my final part. Now, we mentioned before that having a blend radius for something like this is pretty good to prevent that delamination. So let's add that blend radius in, and I will have maybe 0.5. Let that load a little. And now you see there is a surface kind of embossing effect going on. And that is kind of an aftermath of this blend radius addition. So all we have to do now is if we don't want this pattern to show up, we can easily clean it up using a Boolean subtract or Boolean intersect block, which essentially takes away any of the parts outside of the overlapping. So we'll Boolean intersect this with the original part. So we'll take this final part, which is actually a lie. It's not a final part. So maybe we want to double click and change it. Or now let's remove this variable content. So now we have this final part. We can delete it. And now just drag and drop. So now it's not a variable anymore. It's not an actual final part. And then we can Boolean intersect this with our initial gear volume. And you can see now all of that is cleaned up. I will now right click, make this a variable, and call this my real final part. And that's that. So we have gone through that workflow to create our shelled and gyroid part. Now, if we go to this light weighting tab, under shelling, there is a block called shell and gyroid. And that is a toolkit block. And you can tell that it is a toolkit block by seeing that there are 2 lines here instead of 1. And what this does is the exact same thing as this workflow that we have created. So let's input it with, I'm going to go back and grab this gear as my body. I'm going to input the same value as everything that I've used so far. So 5, cell size of 5, approximate thickness 0.5, shell thickness of 1, and then blend radius of 0.5. Let that render a bit. Essentially what this does is the exact same thing packaged up into a block so that we can use this very fast and multiple times for different parts. So if I isolate this view or isolate this block and press X, you can see that we have this same structure. And let's isolate our final part again. That's the exact same structure that we have just created, but very quickly done. So that's kind of what a toolkit block is, that pre-packaged workflow. And if you ever want to kind of see how this was created, you can right click on it and there is an option to export block. You can save this to your folder and then open that up as a normal file, and then you'll see all the blocks that were used to create it. And this is kind of the idea too. If you would create something like this yourself, then it would be called a custom block. So to give you an idea of what custom blocks or when you would want to kind of use this is if we want to perforate this part for removing powder, giving those powder from additive manufacturing an escape hole, for example. Let's maybe make use of our search bar and type in perforate. We have two options, and both of these are toolkit blocks that live in one of the toolkit ribbons or tabs in the ribbon. And one of them is perforate body, so giving that cylindrical holes throughout that entire body. And perforate from CAD face, which you choose which CAD face of that object you want to perforate, and it does that on your implicit body. Now, we have used a mesh file here. So you could also perforate with our mesh file, but you will require a workaround. And I have, let's collapse all of these. I have already gone ahead and created a custom block that does the exact same thing with that perforate from CAD face block, but using a mesh instead. So that's one way to import a custom block, to click on this icon and then import block. So we'll do that. This custom block, CB stands for custom block. Let's choose that and call that in. So now I can choose the things that I want to perforate. So I want to perforate my shell. So pull that in. And then in this gear, we have this mesh already, so we can duplicate it with reference. So there are two options to duplicate. The first one is just duplicating it and then making a new block out of it. Duplicate with reference, make sure that whatever changes happens in one is also reflected in the other. So that shortcut for duplicate with reference is holding Control and dragging it in. So I'm going to do that here. The depth of my holes that I will perforate, I want to be the same as my shell thickness. So I will go into my shell block, make this thickness a variable, right click, make variable, and then name it something that will easily understand what it is, shell thickness, and then drag that and drop into my depth. And then for selecting a surface of a mesh, we have to go in and select where, or put this axis to really close to where we want to have the surface extracted. And so I will do that real quick, move that over. Let's check and see if we have that close enough. Good, so we have that angle. So determining how much of that area we want, perforation, let's put 40. I want my diameter to be 2. So now if I just isolate this by pressing I, we have very quickly, using a custom block, perforated the shell of this. And you would then, if you want this, so let's right click and make this a variable, and we'll call this perforated shell. And then what we could do is we could maybe, so this is essentially one design variation from the shell. So the shell is design variation 1, perforated shell is maybe design variation 2. And you could always kind of put this perforated shell in this Boolean union instead of that shell. And maybe if I want to make it a little bit kind of